Hello everyone, welcome back. Today we are going to discuss level order traversal, also known as breadth first search traversal. This traversal method is different from depth first search traversal on trees, namely in order, pre-order and post-order traversal. To revise or understand BFS in general, please check out the video linked in the I button. In level order traversal, we visit the tree nodes level by level. This means we cover all the nodes at a particular depth or level before moving on to the nodes at the next deeper level. Let's look at this example to understand better. We start with node 7 at level 0, and once we are done with level 0, we can move to level 1 and visit the nodes 1 and 9 from left to right. And then we move to the next level and visit the node 0, 3, 8 and 10. Then at level 3, we visit the node 2 and 5. And finally at the last level, that is level 4, we visit the node 4 and 6. This way we cover all the nodes level by level, and this will be our output. And now the question is, how can we write this programmatically? Unlike linked list, we can't just start from one pointer and move it around. For example, if we start a traversal at the root with one pointer, we can move from 7 to 1 because there is a link. Now we have to go from 1 to 9 because 9 is the next node in the traversal, but we can't move from 1 to 9 because there is no direct link between 1 and 9. Only way we can reach 9 is via parent node 7. Clearly we need a different approach since one pointer is not sufficient. We need some way to keep reference to the parent so that we can process all its children, and that's where data structure queue can help us because it can hold reference to the nodes, making them available for the future visits and operate in first out basis, ensuring nodes are visited in the correct order. So queue is the most suitable data structure for BFS or level order traversal. So we start by enqueuing the root node. For example, for the current tree, we can enqueue root node, that is 7, to the queue. Then we will start the BFS, where we will extract the node at the front of the queue, visit or process the node by adding its value to our answer list, and enqueue its children, that is first the left child and then the right child. And we will repeat this process until queue becomes empty. Now let's see this in action. So first node we pull out is 7 and add it to our visited or answer list and add its children 1 and 9 to the queue. Then we pull out node 1, add it to the answer list and enqueue its children 0 and 3 to the queue. Then the next node we dequeue is 9. We add it to the answer list and enqueue its children 8 and 10 to the queue. Then we dequeue 0, add it to the answer list, and we can see that 0 does not have any children. So we move on with our BFS and dequeue 3, add it to the visited set and add its children 2 and 5 back to the queue. Now we dequeue 8, add it to the visited set, and it also doesn't have any children. So we dequeue the next element from the queue, that is 10, add it to the visited set, and it also doesn't have any children. So we dequeue 2 and add it to our visited or answer list, and it also doesn't have any children. So we dequeue 5, add it to the answer list, and enqueue its children 4 and 6 to the queue. Then we dequeue 4, add it to the answer list. It doesn't have any children, so we dequeue 6 and add it to our answer list, and it also doesn't have any children. And finally queue is empty, so that means we are done with our level order traversal, and this will be our answer. Now in terms of time complexity, it will be O of n, where n is number of elements in the binary tree. This is because we are visiting each element only once, so that's why the time complexity is O of n. And in terms of space complexity also, it will be O of n, because we are using this queue to store these elements, and in the worst case, for example for the completely filled binary tree, the last level will contain n by 2 nodes, and at any point queue is storing the nodes from at most 2 levels, which is still proportional to n. So the space complexity is O of n. And finally, if you are still interested, let's cover the code as well. First, let's initialize the queue for level order traversal. We can use linked list implementation in Java for that. Let's add root node to the queue. Let's also create our answer list to store the level order traversal. We can use array list or linked list implementation for that. Now we will start the BFS. So while queue is not empty, we will dequeue the node and add its value to the answer list. And now we enqueue its children. First we check for the left child. If the node has left child, then we add it to the queue. Similarly, if the node has right child, then we also add it to the queue. And once we are done with BFS, we will return our answer. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.